Thanks, Tom. Good morning, good evening, good afternoon, depending on where you are. My name is Janakiram. As Tom mentioned, I'm based out of Hyderabad, India. It's currently 10:30 p.m. for me, and I'm looking forward to spending the next 45 minutes with you on how to deal with data in IoT scenarios with RESTful backend. So let me set the context by sharing the agenda, and then I'll briefly share my experiences and where I come from, and then we'll delve into the details about IoT RESTful backend. So I'm going to start with a developer perspective of Internet of Things, because IoT means different things to different people, but most of us are developers, so I want to put things in perspective for the developers. What exactly is IoT for a developer? Then I'm going to spend considerable amount of time walking you through the overview of DreamFactory Services Platform, which we commonly refer to as DSP. So every time I mention DSP, it's going to be pointing to DreamFactory Services Platform, not necessarily digital signal processing, which also happens to be a terminology used in IoT in the context of embedded electronics. But DSP in this case refers to the IoT platform that we are using in this. Then I'm going to talk to you about REST and IoT, how they are related, and how REST plays a crucial role in the data ingestion and streaming and visualization and so on. Then I have a pretty interesting demo on using Raspberry Pi for storing and visualizing data. So we are going to see some real-time dashboards that populate the data as it comes from multiple sensors. So that's the agenda. Let me just tell you where I come from and what I do. I am an architect, advisor, and an analyst. I write for Forbes, covering the cloud, DevOps, containers, and IoT landscape. My prior experience includes working for Microsoft Corporation, AWS, and Bell Labs. I'm certified on 3 different cloud platforms. I'm a Google developer expert on Google Cloud Platform, Microsoft Regional Director focused on Azure. And after my stint at Microsoft and Amazon, I founded a cloud consulting company that got acquired in 2013. And since then, I have been an independent analyst and advisor. So IoT happens to be my newfound love. I'm pretty excited and passionate about connecting the things to the cloud. And I truly believe when we bring things, software, and cloud together, the magic starts to happen. So it's a very fascinating world out there. And I want to spend next 45 minutes giving you a glimpse of what it really takes to connect the real world things and objects to the cloud. And in that process, how do we deal with data that's going to be generated by these things that we are going to deal with? So what exactly is IoT? But before even I get there, I want to bring up a poll question to get a sense of my audience, right? So you would actually see a poll in front of you. So I want you to spend few seconds and respond to this. This will give me a good idea on how to structure my discussion with you. Okay, so if you are done, we can get back to the presentation. I want to see the okay, interestingly, I'm not able to see the output of the poll, but okay, there we go. So a lot of you have mentioned that you are a beginner. So that's not surprising, given the fact that IoT is a very new area and a lot of us are still learning. I consider myself as an IoT enthusiast, so I'm still somewhere in between beginner and intermediate. So this is going to be interesting irrespective of the learning curve that you are in. So thanks for participating in this, and let's get back to the presentation. Excellent. So Gartner believed that the IoT phenomenon was peaking the hype cycle back in 2014, and typically whatever Gartner positions at the peak will really become realistic and mainstream in about 18 to 24 months. So if Gartner put IoT right at the peak of hype cycle in 2014, we are just at the beginning of the IoT adoption. So this is the best time for us to start considering IoT for our projects, for our career, and various investments that we're going to make. So IoT means multiple things, for consumers, for developers, for enterprises, industries. But why now? Why exactly is everyone talking about IoT at this point? There are multiple factors that are primarily contributing to this phenomenon. The first one is hardware is becoming extremely cheap. Now, when I say hardware, I mean everything in the spectrum, all the way from tiny sensors that capture a variety of environmental details to even slightly more powerful devices like smartphones and even tablets and PCs and so on. Interestingly, the phone in itself is actually a mega sensor. Most of the smartphones that we use have an accelerator, a gyrometer, a GPS, a touch sensor, and a variety of other sensors that actually collect the data, but we don't treat them as a true IoT sensor device. But in a lot of sense, a phone is actually a sensor, a collection of various sensors. So it's a device that aggregates multiple sensors. And we know the prices of smartphone is dropping regularly. So that is one trend that is contributing to bringing Internet of Things into the mainstream. Then connectivity is becoming pervasive. It's impossible to think of a place that doesn't have connectivity, whether it's on flight or in a coffee shop or at home. Wherever you go, you need Wi-Fi, you need connectivity, and it is becoming almost a basic expectation to have Wi-Fi connectivity these days. So that is becoming absolutely pervasive, and it's ubiquitous. So even emerging countries and developing countries are experiencing a huge connectivity increase across households and across enterprises and so on. The third one is development is becoming easier. Of course, this is constantly a phenomenon that happens in the IT landscape. While the development becomes easier, the complexity also increases. But currently, the tools and the IDEs and the libraries, various open source projects are actually making interacting and interfacing with hardware much easier than what it was just a 2 years ago timeline. So development is becoming much more easier, and the learning curve is very short when compared to what it was earlier. And that is driving multiple benefits, particularly for consumers and even enterprises. More on that little later. And by connecting these devices to the software and then eventually to the cloud, we have very innovative scenarios, from connected cars to connected homes to smart healthcare to a variety of imaginative scenarios that are playing a key role in our daily lives. So just to give you some examples of connected devices in the consumer landscape, Google is working on self-driven cars, and that's one of the example of a connected car. Imagine sitting in an Uber that doesn't have a driver, but there are multiple cameras that are sensing the traffic conditions in real time, and that transmit the data to a control center, a command center that can track the route and that can make the car take smart decisions on the fly, on the move. That is one example. The band that you see here called Lumo is a gesture recognition band. So as IT professionals, we lead a sedentary lifestyle, and we don't exercise enough, we don't stand in the most ergonomic form. But when you actually wear this band like a belt, it's going to alert you when you're not standing upright or when you're straining your back and the spinal cord. So it uses a variety of sensors to track your posture and warns you when you're hurting yourself by standing in a wrong posture for a long time. So That is one example. Then GoPro Hero is another camera that streams adventure sports in real time. This is worn by a lot of athletes and a lot of adventure sport fans. So we can pretty much participate in their journey by seeing through their eyes, because they wear a GoPro Hero or a GoPro Cam on their helmets, and it's a very immersive experience that you go through. Then Nest, Dropcam, which are a part of Google, are very common names in the US household, and they are pretty much revolutionizing the way you do monitoring, surveillance, and also smart thermostat, temperature control, energy management, and so on. So there are a variety of devices in the consumer space. But at the same time, IoT is redefining enterprise and the on the industrial segment as well. Things like connected health, connected car, connected cities, which is also called smart city, and connected living, all these are billion-dollar opportunities, and companies like IBM, Cisco, Juniper, Samsung, LG, GE, all of them, Bosch, all of them are investing in bringing in a lot of automation and real-time monitoring to traditional manufacturing, healthcare, retail, and so on. So IoT is just not about wearing cool gadgets or just controlling your home automation. It goes much beyond that, and the real opportunity exists in the enterprise and the industrial IoT segment. So having established IoT use cases, let me touch upon what it means to you as a developer. How do you get started with IoT? I get this question multiple times, and a lot of my friends and a lot of my Twitter followers and other attendees keep asking me, how do I get started? How do I write my Hello World IoT program? It's not very difficult. It's not very hard. You can choose one of the do-it-yourself development boards or development platforms. There are a variety of them. The most popular is called Arduino, which enjoys a huge community and a very vibrant ecosystem. And I would strongly recommend you to go ahead and get yourself an Arduino Uno R3 or the recently released Arduino Zero and get started with that. There are many resources for you to get started. In fact, there are kits that come along with Arduino for you to wire up little sensors, actuators, connect them to your PC and start experiencing your first IoT development cycle. Similarly, there is Raspberry Pi, which is used in a variety of use cases. A lot of people use Raspberry as a home media center, and it's also used for running slightly high-end software, like video encoding and media management and so on. Then there is another platform called BeagleBone. Then a very tiny Wi-Fi enabled microcontroller called Spark, which is now renamed as Particle. Then Adafruit has a set of wearable Arduino based circuits and development boards that you can use for prototyping. The more recent ones are Intel Edison and Intel Galileo. Intel Edison is extremely powerful. It takes you from prototyping to production in the shortest possible path. And Intel Galileo is more aligned with Arduino ecosystem, and you can port most of your Arduino sketches and Arduino programs to run on Intel Galileo. And LittleBits is actually meant for kids, but the Arduino coding kit and the cloud bit take LittleBits beyond kids to even adults. So you can actually start your Hello World with LittleBits. That's not a trivial platform. So this ecosystem makes it possible for you to get your feet wet with IoT development. So I want to pause a little bit and ask you let me come back to this in a second, but I want to ask you which IoT prototyping platform you have used earlier. Okay, please take a second and click on a few options. Excellent. I'm not surprised. Arduino and Raspberry Pi top the charts. 1% use BeagleBone Black, which happens to be my favorite platform, and others is 26%. I guess there are many other do-it-yourself platforms that the attendees are familiar with. Excellent. So let's get back to the slides, and I want to walk you through a very interesting perspective here, and this is the crux of our session today. So when you get started with IoT, what does it really mean to you as a developer? There are multiple layers when you're developing an IoT solution, and as a developer, you have a role to play in all these layers. It starts with devices, but I think this is an area where you have the minimal role to play, and this is best left to electronic engineers or instrumentation engineers or embedded professionals, because these contain the sensor nodes. Sensor node is essentially a combination of a sensor, a microcontroller, a power unit, and a communication radio. So when you put all of them into a self-contained unit, it is typically called as a sensor node. For example, Arduino Yun, if you are familiar with it, can be considered as an independent standalone sensor node. Or similarly, an Arduino Uno 3 with a humidity and temperature sensor with a LiPo battery, NXB radio is essentially the job of either interact with the real world objects through an actuator, which is a switch, or grab the data from a variety of sensors. So that is the only electronic device that you would deal with. Now, these sensor nodes constantly stream the data, and this data needs to be aggregated. And the job of a gateway is precisely this, which is collection of data and aggregating data. So imagine in an industrial scenario where there are multiple manufacturing units, machines, and every machine has half a dozen sensors, and we need to collect the data from multiple machines, multiple sensors, and we have to aggregate it at the floor level. We can deploy a gateway at every floor, and it's going to be responsible for collecting the data and aggregating the data from all the sensors, all the machines deployed in that specific floor. And then these gateways will further stream the data either to cloud or to a local data center, and that process is called ingestion. So ingestion is streaming the real-time data after the gateways consolidate and aggregate the data, because the sensor data may be or may not be useful in its raw form. So the job of a gateway is to normalize the data by adding additional information. A very trivial example is adding a timestamp, and for example, converting the device ID to a specific plant ID or a machine ID by using some reference data. So gateways will help us make sense of the sensor data, and then that data gets streamed in real time to the cloud. And that is real-time streaming. There are a set of services that play a role here. Open source software like Apache Kafka or Amazon's Kinesis, Microsoft Azure's Event Hubs, and Google's Cloud PubSub, all of them play a role in ingesting the data to the cloud. So once the data is streamed and goes through a variety of phases, it ultimately gets stored in a structured and an unstructured data set. So this is where we have traditional relational databases, contemporary NoSQL databases, and object storage playing a role. So if you're on Amazon's environment, you would store some unstructured data on S3, structured data in RDS, which is MySQL or SQL Server, and semi-structured data in DynamoDB. So that data is going to be persisted in one of these sources. And then the same data is going to be used for event processing. For example, as the data gets committed to the database, you want to trigger an event which will talk back to the machinery or to the manufacturing plant or to the warehouse or alert appropriate individuals. So all the complex event processing or CEP happens in this place. there is a little bit of a deviation here. The event processing happens at two different levels. One is at the ingestion level, right at the real-time streaming level, and also after the data is persisted. So the data that is analyzed and processed as it enters, that is called the hot path analytics, because that is happening in real time. And the data, the analytics that work on the data that is persisted and which typically happens in a batch processing mode is called the cold path analytics. So both these analytics will result in complex event processing and alerting, and that is leading us to engagement and analytics. So engagement is sending push notifications or alerts to end users or appropriate individuals or even machines or things. And analytics is creating powerful dashboards that make sense out of the information that the IoT engine is mining. So this is actually the full stack of IoT, and as developers, we are going to play a crucial role in all these phases, right? All these phases. So we have seen this earlier. So now, how exactly are we going to use REST in this scenario? Well, REST plays a very crucial role because irrespective of the technology, irrespective of the development platform, database, you are going to use REST across the stack. REST stands for representational state transfer, and this has become almost a de facto protocol for the web, and this is understood by almost every web server, every endpoint, and every service that is out there on the internet. So IoT leverages a lot of REST endpoints. Of course, there are other protocols like MQTT, which is a telemetry message queuing transport protocol. Then there is a constrained application protocol, but they are not very mature. They are still evolving. The standards are yet to be finalized. But currently, a lot of services, right from ingestion to storage to analytics, still rely on REST. And because REST uses HTTP, you can actually consume REST in very, very tiny devices, even sometimes straight from the sensor node. For example, it is quite possible for you to invoke REST API and REST endpoints straight from an Arduino Yun or a Spark core or a Cloud bit, because all of them can make outbound calls. So you can quickly wire up variety of things by using REST as the glue that's bringing multiple services together. So I want to ask you a question before we get on to the next section, which is introducing you to the DreamFactory Services Platform. How many of you are familiar with DSP? I assume most of you, because if you have signed up, either you are following the blog of DSP or you have been using it. But I'm just curious to see how many of you have used it in your applications. Okay, so while you are still on answering, okay, so there are about 39% of you who used DSP and 61% haven't used. So I chanced upon DSP when I was prototyping one of my IoT solutions. I knew DSP more as a mobile backend as a service, but I ended up using DSP for an IoT scenario, and that's when I got in touch with DreamFactory Services Platform, and I started working with them on a few use cases and scenarios. So let's get back to the slides, and I want to introduce how you can use DSP in various scenarios. So what exactly is DreamFactory Services Platform? So as I mentioned, today persistence is not dealing with just one database. If you look at the way we are dealing with persistence, there are two different spectrums. Data is generated from a variety of sources, and the data is persisted at a variety of destinations. So unstructured data goes to object storage like Amazon S3 or Azure Blob or Google Cloud Storage. Semi-structured data goes to MongoDB, Cassandra, DynamoDB, Azure Tables, DocumentDB, Google Cloud, Bigtable, and so on. Then traditional relational database, transactional data goes into ANSI SQL compliant ACID databases, and that is Oracle, SQL Server, DB2, MySQL, PostgreSQL, and so on. Now, as a developer, it's very, very challenging for you to deal with the proprietary APIs that are exposed by each of these data sources. For example, to integrate one unstructured, one semi-structured, and one structured database in your application, you have to deal with at least 3 proprietary APIs. And that makes you not so much productive, and also makes your code error prone, because you are mixing and matching highly heterogeneous API into your applications. Now, what is the value proposition of DreamFactory? Why should you use that? And what problem do they solve? So DSP is a single unified facade that exposes a consistent REST API for over a dozen data sources. So it doesn't matter what kind of data source you deal with, you always end up using a very consistent, uniform set of REST endpoints. So it almost gives you a JDBC or an ODBC standard, where you keep your entire code and queries as is, but you just change the connection string and everything would work. Very similar to that, you can actually standardize your code on REST, and you change one line, which is the endpoint, and you can use the same API to talk to S3 or Cloud Storage or Azure Blobs or MongoDB or Cassandra or DynamoDB or Azure Table, or exactly the same REST interface to talk to Oracle, SQL Server, DB2, MySQL, or any other relational database. So this gives you a unified, universal data access layer to deal with all things data. It doesn't matter what kind of database you're actually going to deal with. You always have one unified, consistent REST interface to look up to. So that is basically what is called as the DreamFactory Services Platform. In the recent release, DSP has increased the capability. They go beyond exposing the API facade. Now it's possible for you to implement authentication that is integrated with Active Directory and LDAP. You can create user management. You can create users that tie with role-based access control. You can create a variety of triggers on a database API that may not be supported natively by the databases, but you can still create hooks that will get triggered when you perform actions on any of the supported databases. So this is the engine that abstracts the complexity of the underlying database APIs by exposing simple, singular, unified REST API. And this engine can be used when, irrespective of a desktop application, a web application, a mobile application, or an IoT application that you're developing, because this becomes your universal data access layer, right? So what if you are going to deal with a database that DreamFactory doesn't support? You can register your third-party API and still treat that as a part of the DSP API. So that gives you a chance to consolidate your APIs into one endpoint. So you can bring in your custom endpoint and register it with DSP. So you can pretty much integrate any third-party API or a third-party database with DSP and integrate that with the standard REST API that you get. All right, so how is this relevant in the IoT scenarios, right? This is a very powerful use case, and I want you to pay attention as I walk you through a variety of steps, because it's going to be a little tricky. I normally do this demo in front of live audience with a camera attached to my podium, where I wire up sensors and wire up multiple radios and stream the data, but it's going to be very challenging for me to walk you through this demo while you're just staring at my presentation. So let's see how this goes. So let me walk you through what I'm going to do in the next few minutes. So the scenario what I have here is going to be simple. The objective is pretty straightforward. We want to grab the sensor data and visualize it. And we want to do it with minimal code and in a very short learning curve. So the bill of materials for this demo is as follows, right? I have an Arduino Uno R3 connected to 3 different sensors. The first one that you see here, which is slightly bulkier, it's a DHT22 humidity temperature sensor. The next one that you see is actually an LDR, which is a light dependent resistor, which helps us in getting the intensity of the light. It doesn't really give us the luminance, but it does give us the intensity of the light in the room. Then the third sensor that you see is a simple electric mic. We treat that as a sound sensor. Again, it's not going to give us sound in decibels. It's not highly scientific, but it gives the intensity of sound in the room. So I'm connecting 3 sensors to the microcontroller, and the microcontroller is connected to my Mac through the serial port. And on my machine, I'm running a virtual machine that has the DreamFactory Services Platform installed. I could also run this on EC2 or Google Cloud or Azure, but I chose to run it on my local machine. So what I do is I use a script that grabs the data from the serial port and passes that on to DreamFactory's REST endpoint, and then that commits to a MongoDB, which is running inside the VM. So, and this MongoDB data is later on used for visualization, which I'm going to walk you through. So it's a pretty straightforward scenario. You can think of this as a 4-tier application. The first tier is the sensor tier, which has a bunch of sensors in the microcontroller. The second tier is the streaming tier, which is my Mac, which is responsible for grabbing the data from the serial port and ingesting the data. And the third tier is the DSP REST middleware. For all practical purposes, it's a middleware which is responsible for grabbing this data that is streamed from the machine into REST and subsequently into the MongoDB format. So the fourth tier that we have is actually the data tier, and I'm going to extend this further, maybe to the 5th tier, which is a visualization tier, and that is going to be the engagement layer. So in a way, we are covering all the things, but let me walk you through this demo. So I want to switch to a VM here, okay? So I have a VMware Fusion VM running on my machine. This is downloaded from Bitnami's DreamFactory repository. All of you can get this. Just go to Bitnami and search for DreamFactory. Download the latest VirtualBox or VMware image. It's the easiest way for you to get started. This is currently running the DreamFactory distribution. So when I go to the apps directory, you notice there is DreamFactory in this. And this is currently listening on an IP address which I'm going to access from my machine, just to show you how DreamFactory looks like. At the same time, I want to show you that MongoDB is already installed. So I can query my existing collection. I have a database called WeatherDB, and I think I have a table called weather, and I want to query this for sensor type, which is light. So I want to just try if MongoDB is up and running on my VM. Okay, so there you actually see some data which is in JSON. So that actually shows that we have MongoDB up and running. That's perfect. Now what we need to do is to grab the sensor data and populate MongoDB running inside this VM. So let me switch to the browser. And so what I have done is, to make this simple, I have added an entry to my etc host. So I'm going to call this DSP, right? So don't get confused. It is basically pointing to the same VM. So I'm going to type HTTP DSP. So this is going to take me to the Bitnami VM that I'm running on my local machine. So this shows us the DreamFactory console, right? And here you can create multiple applications. But what I have decided to do is to register one of our services. So this service is actually pointing to MongoDB. So I have registered a NoSQL database. So here when you, for example, click on create, you can create an API for a variety of services from a remote web service that is not listed or supported by DSP locally, a remote SQL database, a NoSQL database, Salesforce, local file storage that acts as an object storage, remote file storage, email, and push service, which is SNS. So this gives us a good spectrum that we can consume from our applications. So I have registered my MongoDB service by pointing it to a NoSQL database, and the name of the API is Weather Station. And I have chosen MongoDB as a NoSQL vendor. You can choose from Amazon DynamoDB to SimpleDB to variety of databases. This list is only growing, and it's pointing to localhost. Database name is WeatherDB. We just queried it from the Mongo shell running in the VM. So once this is done, I can also look at the schema. So I select my database. Okay, I want to go straight into my API docs. I don't have enough time. So, okay, I guess most of you are familiar with Swagger. So the cool thing about DSP is Swagger is integrated right into the platform. So when you click on API docs, you go into an interface that is integrated with Swagger. So Weather Station is already showing up here because we registered under services. I can go to Get Tables and click on Try It Out button. That quickly shows us there is a table called weather, and it's an indication that everything is set up perfectly. Now I'll come back, hide this guy, and then get records, right? So I can query weather table, and I want to limit to 1. You can also run SQL-like filters. So sensor type is temperature, and I just want to try this out. Okay, and there we go. So now it actually throws a JSON object, right, which is showing the temperature along with some metadata. So this is perfect. So everything is set. We have the middleware configured. We have the database schema created. Of course, we are using a NoSQL database, but all the things are in place. Now comes in the code to stream this data to populate into our database, right? So I bring up Arduino. So what you see here is Arduino connected to my USB modem, blah, blah, blah port. And this is not very readable. So I'll take you to Sublime Text, which will make it much more readable. So if this is the first time you're seeing an Arduino sketch, it looks very similar to C. And unfortunately, I don't have a lot of time to do an Arduino 101, but you get an idea that I'm connecting the humidity and the temperature sensor to analog 0. Analog pin 1 is connected to sound sensor, and pin 2 is connected to a light sensor. So in the setup, which acts as like a constructor, I'm grabbing the input, I'm configuring the pins as the input, and I'm introducing a bit of delay because I don't want to overrun the sensors. And I initialize my library for the DHT, which is an abstraction for dealing with the complex humidity and temperature sensor. And that gives us high-level functions that we can call read humidity, which does all the magic of converting the voltage into temperature and humidity. So this abstracts the underlying math, and then I'm reading the analog value coming from the light sensor, and the same thing for the sound sensor. A little bit of validation, and if everything goes well, I basically print a comma separated string, which is going to print humidity, temperature, light, and sound in one line. And then I wait for 100 milliseconds. So that is basically the sketch that I have here. And I'm already connected to my port. So let me go ahead and push this, right? So this sketch is being compiled and is ported to Arduino. So how do we know if this is successful? I click on the serial monitor, and there we go. It shows us a string that is generated frequently, and this string is an indication that I'm sitting in a room with high humidity, 68.6%, and the temperature is 28. The light intensity is about 400, 300 odd, and the same thing goes for light. So that's a good indication. Now what I'm going to do is come back to my terminal and go to so open this program, which is actually acting as a gateway. So what it does is pretty simple. I use a popular service called UniRest. So UniRest gives us a nice Python library. It actually supports multiple languages, and it gives you a very cool library to deal with REST. So I use the UniRest library to get authenticated with a DreamFactory platform. So here you see I'm calling the username and password in clear text. This is not going to be done in the same way in the production. And that's going to throw us a session ID, which we'll use for subsequent authentication calls. And later on, I'm going to open a connection to the serial port, and I'm going to delimit the, split the string by the delimiter, and then get the values like room ID, device ID, sensor ID, and populate an array, which is going to be, again, posted to DSP through this URL. So I'm basically creating a Python array. Ultimately, the weather record is going to contain a huge array of all the sensor data, and we are going to post that to the endpoint exposed by DSP, and we are going to use this as a header. So weather station is the app name, and the session token is what we grabbed from the first line where we got authenticated. And that's it. So this code is now responsible for grabbing the data from Arduino and streaming it to our MongoDB via DSP. So let me come to the command prompt and execute this code. So now this code is acting as an ingestion, right? An ingestion layer come aggregation layer, because we are aggregating the data coming from technically multiple sensors, multiple rooms, multiple nodes, and we are adding a little bit of timestamp and transformational data, reference data, and then ingesting that to the cloud. So now this data is getting added to DSP, and if we come back to the Swagger UI and do an order by time in descending, or actually ascending, right? It should give us the real-time data. So as I keep refreshing this, you will notice we are grabbing the temperature data in real time. Now, this is pretty powerful. What I'm going to do now is to build the fifth tier of our application, which is actually the dashboard, right? So I have an open source tool called Freeboard. And what Freeboard does is pretty straightforward, right? So I can add a URL. For example, let's call this weather station, and the URL comes from here. So this is the URL that I'm going to grab, right? And refresh every 1 second. That's going to be pretty fast. And I'm going to add a couple of headers, and those headers actually come from the same thing that we have here. So I'm going to add the application name, which is the weather station. And I'm going to add the authentication header as well, because even the freeboard dashboard needs to be authenticated with DSP. So I'm going to grab this from my console because this session is very important. So I'm grabbing it from the current session and populating the freeboard, and I'm going to save this. So now we are actually grabbing the URL, and I'm going to add a pane and create a gauge, right? So let's call this temperature. Value is coming from the weather station data source, right? And we are going to grab the sensor value. Unit is Celsius, somewhere between 1 and 100, and save this, right? And there we go. So now we have a dashboard that is actually getting visualized in real time. And this is the 5th tier of our application. First tier is a sensor node. Second tier is the Mac. Third tier is DSP. Fourth tier is a MongoDB. And 5th tier is what we have as a dashboard, right? But we have multiple other sensors. Where is that going? So to save time, I didn't want to build it multiple times. So what I have done is I have created an existing one, which I want to load. So desktop, webinar, demos, local, and I have exported a dashboard, which I want to import now, right? So this is going to be populated in a few minutes because it's going to warm up and then make a call, get authenticated. But very soon, in some time, we'll actually see a full-blown environmental dashboard that shows us the live humidity, temperature, light, and sound of this room, right? So it's pretty powerful. So this is not even related to cloud. Everything is happening inside my machine, and we are able to do this end-to-end. This is going to take a little while because I have to change some parameters, particularly things like the authentication metric. But you get an idea. Unfortunately, I don't have a lot of time to build an end-to-end dashboard, but this is a live dashboard that you're seeing, right? Now I can construct multiple other URLs and quickly create a full-blown weather dashboard that we can track. So that is one scenario. Let's come back to the slides. This becomes very powerful when we are able to run DreamFactory on Raspberry Pi 2. So Raspberry Pi 2 comes with almost a 1 gigahertz, to be more precise, a 900 megahertz processor, 1 GB RAM, and a full-blown Debian distribution called Raspbian. So you can install a full-fledged LAMP stack on it. So I actually tried running LAMP on it, and then I installed DreamFactory on Raspberry Pi 2, and it just runs. So it becomes a pretty powerful scenario. And I have taken the same scenario to the next level, where we don't even need to use a Mac, and we actually construct a pretty powerful use case, which can be used in mainstream industrial IoT scenario. So everything remains the same as far as the sensor node remains, but I disconnected my USB, which is streaming the serial data to my Mac, and I connected a radio called XB, and that uses a very low energy, high efficient radio protocol, a wireless protocol called Zigbee. So this is running in a corner of the manufacturing plant, and there are multiple of them in the production scenario. And for every floor, we have a Raspberry Pi, again connected to an XB radio and running a MySQL database locally along with DSP. So multiple microcontrollers and sensor nodes will stream the data wirelessly to Raspberry Pi. It aggregates the data and caches the data in the local database. And at every 1 hour or so, it's going to consolidate and throw it to Amazon's DynamoDB. So the deployment architecture is going to look something like this. So you have an Arduino Uno 3, which is acting as a sensor node, and we have multiple sensor nodes deployed, and all of them are talking to Raspberry Pi over a Zigbee wireless link through an XB socket. and Raspberry Pi 2 aggregates the data. So that plays the role of a gateway by aggregating the data. So in terms of software, this is how it's going to look like. So you have multiple sensor nodes, and these sensors are grabbed by Raspberry Pi, which is running a data aggregated daemon. It's running as a cron job. So it periodically grabs the sensor data coming from multiple sensor nodes and calls the DreamFactory API platform, pretty much the same code that I have shown you earlier, and that caches to the local database. I couldn't manage to run MongoDB on Raspberry Pi because Mongo hasn't ported to an ARM platform. So running it on a Cortex or a Broadcom chip was very difficult. So I could manage to run MySQL. So I'm currently caching the data in a local MySQL database, but I don't want to overwhelm the Raspberry Pi and an SD card with so much of data. So what happens is there is another cron job that kicks in and refreshes the local database and streams that to Amazon DynamoDB. So once the data is validated and the cloud data is committed, the local database gets refreshed. And we actually export and dump it on the cloud just for referential integrity. We don't really cache it locally, and we use certain streaming and alerting logic on the local data. So this is a deployment architecture, but you don't see a machine here. It's all based on Arduino and Raspberry Pi. So I want to show you the other part of the demo in limited time that we have. So let me come back to my command prompt. So I have created a host entry for my Raspberry Pi. It's called rpi2, right? So you'll see it's resolved to an IP address. So I can SSH to my Raspberry Pi 2, which is on the local same network. Okay, so this is where we have DSP running, and when I go to, okay, you actually notice that we have the same code that we ran locally, right? So this is the gateway code running on DSP. The only difference is the URL is localhost, which is pointing to 10.0.0.10, which is resolving to localhost, and it is using a serial port that is specific to Raspberry Pi, and everything else remains the same. That is the beauty of using DSP. Highly consistent, same code that you can use, and nothing is changed. The only difference is we're actually using a wireless connection to make Arduino talk to Raspberry Pi. So once we have this data coming in, I can go back, and if you actually notice my browser, I'm using DSP running on Raspberry Pi. So this is 10.0.0.10, and I also have a PHP MyAdmin installed on Raspberry Pi. So I can go to weather station database, log in, and do a quick query. Right, so this is my weather table, and you'll actually notice that the same sensor data is being streamed to Raspberry Pi, and we have the same freeboard. I can load an existing one. So this dashboard also gets populated in few minutes, and this is going to be pointing to the data that is getting streamed to Raspberry Pi. So this is a real use case of using Raspberry Pi as a gateway, which is powered by DSP platform. So you get an idea. I actually covered two different use cases. One is DSP running in a VM and acting as a middleware, VM or a cloud instance, or you could also run DSP within Raspberry Pi and get rid of an expensive PC or a Mac and consolidate and aggregate data into Raspberry Pi, cache it locally, run some real-time alerts and events, and then stream it to the cloud periodically. So the good news is I'm actually in the process of creating a tutorial for this. It's going to be posted on a popular developer portal. And since all of you are registered, you're going to get a link to this when that is live sometime this month, towards the end of the month. But my suggestion is go ahead, give it a shot, download the Bitnami appliance or spin up Bitnami on Google Cloud or Azure or your favorite cloud platform and try it out. So this brings us to the last question. So how do you rate this? Can we have the poll, please? Okay, we really appreciate your feedback, so it'll be great if you can. Thank you so much. Thanks, that's a very encouraging feedback. We really appreciate it. This webinar will be recorded and will be shared with you. So you'll be receiving an update once it is live on our blog. So question time. Let me bring up the questions tab and see if there are any interesting questions. I'm not able to see the questions. Maybe they need to be promoted from the
Johnny, let me try
organizer.
To make you the organizer and you should be able to see it.
Okay.
Well, I don't think it's going to let me swap. Johnny, let me just feed you some of the questions we have on here. Will that work for
you? Sure.
Okay. So one question is, how can I upload my sensor data to store on the cloud?
Well, I partially answered that during the demo. So you have two choices. One is you can cache it locally on a database, or you can use the cloud storage API to ingest directly. And you can use DSP as a standard API for both.
Great. And a lot of questions here about if this is going to be recorded so we can share with other colleagues and whatnot. And the answer is yes, we are going to have a link for this that'll be emailed out to everybody who registered. That'll have a live stream of the, or have a stream of the recording itself that you can share with anyone you'd like. So just a couple other questions here. We're just about out of time, so we'll try to get to maybe a couple more. And we have a question here that I can help with, which is how much does the DSP service cost? DSP is an open source product, so it's free to use. And if you go to DreamFactory.com, you can find out quite a bit about it and how to get it. And you're welcome to use it. It's open source and free for everyone. We will have an enterprise version of the tool that'll be available later in the year that'll add some features on that will be a paid-for product, but the core product is open source and free to use. So a question here about what is your, I think you answered this as well during your presentation, but what is your, out of the devices for getting up and running with IoT, what is your favorite?
So my favorite is Arduino. I'm a big fan of Arduino, and I use all sorts of cloud libraries and cloud platforms to experiment. But as I mentioned earlier, I would strongly recommend you to get started with Arduino, which has the smallest learning curve.
Okay. I have a question here on what is the time delay in taking, what is the time delay for your dashboards to populate during the demo? Where does the delay lie?
It's almost real time. I just had to configure it for each of the metrics that I had to, because every metric is a separate URL and I had to authenticate it. So in the interest of time, I just showed you how I could populate a temperature, but there is absolutely no delay. It can call the REST API every 1 second, and as the data gets streamed and it gets persisted, the REST API gets invoked and the visualization is refreshed. So the delay is almost few milliseconds. You can't even really make it out.
So question here about speed difference between the cloud and rather than local host. Do you have any comments on the difference in speed of doing things with the cloud versus a local host?
So it's a very scenario based. More than speed, if you are looking at scale, then you would move to cloud. But if you need real-time alerts and you can't afford to introduce the delay between your local data generation and ingestion and analytics, then you got to do some kind of processing locally. But cloud is the preferred way because of the massive scale it offers and the technologies like PubSub and alerting and complex event processing, containerization, microservices, all of them bring a lot of value. So it is very specific to the use case. There is no specific recommendation for that.
Okay, great. Let's do one more here, Johnny, and we'll wrap it up and do follow-up. We have a lot of other questions, but we'll do follow-up for those. We'll send out some emails afterwards. We do have your email address with your questions, so we'll try to get to those, answer as many of these as we can after the session. But for our last question, what considerations about high data volume do you have to take when setting up your transfer and storage technology?
Sorry, could you repeat that?
Yeah, what considerations for high data volume do you have to take when setting up your transfer and storage technology?
Right. So DSP is relying on REST, and it is a great facade to databases. But if you are looking at more transformational aspects of data, you have to use slightly more complex technologies like, for example, Apache Kafka, which is meant for ingestion, and for transforming the data in real time and in high velocity, you can use Apache Storm. And for performing real-time analytics, a lot of enterprises and industrial IoT customers are using Apache Spark. So a combination of Kafka, Storm, Spark, and an analytics engine, a visualization engine like a Pentaho or a Tableau, is actually what makes it as a full-blown, highly scalable, massively complex IoT stack.
Great, Johnny. Thank you very much. And I want to thank everybody for joining today. We still have a whole lot of questions out there, but we will do follow-up emails to you guys after the session's over and hopefully get those answered for you. And I want to thank everybody very much for your time today, and especially thank Janakiram MSV here for his incredible presentation, which was very illuminating. So thanks, everybody, and have a great day.
Thank you.